This is Synchronous System Practice Homework 6.2, Question 2. Apply the symmetry property to the appropriate pair in table 4.1, which is this table, and show that first one is the original form is this one, and the Fourier transform is u omega. And according to the table, the pair 11, we know that if the original is omega t, so its Fourier transform is pi delta omega plus 1 over j omega. So if this is ft, then this part is f omega. And if we use the duality property, property, we can get u minus omega. The inverse Fourier transform is 1 over 2 pi times pi delta t plus gt 1. So for this, we can just treat it like 5 f minus omega, and this part is the inverse Fourier transform capital T ft. And we also know since the f minus t equals to capital minus omega, we can get u omega 2 pi 1 over 2 pi and pi delta minus t minus gt. So we can get 1 over 2 delta minus t minus g pi t 1. And also, since the delta minus t equals delta t is even function. So we can get the u omega, the inverse Fourier transform, we can equal 1 over 2 delta t minus j pi t 1, and this equals to delta t plus g over pi t, which is the answer of A. And for the next question is B. Also, based on this table pair 9, the cosine, we can get, we write the pair 9 first, write it down, which is cosine omega 0 t. Its Fourier transform is pi delta omega minus omega 0 plus delta omega plus omega 0. And if we say this is ft, then this is the Fourier transform. And also, again, we apply the duality property. We can get cosine minus omega 0 omega and its inverse Fourier transform, which is delta t minus omega plus delta t plus omega 0. If we see this is f minus omega, and then this part is the inverse Fourier transform. And we also know that since the cosine function is even function, so we can get, for this part, actually it's equals to cosine omega 0 omega. And we regard our set omega 0 equals capital T and times 2 at both sides for this pair, so we can get 2 cosine omega t, and the right hand side is delta t minus t plus delta small t plus capital T, which is the answer of this question. And for the C, we can see the sign. So let's see the table 4.1, which corresponding to this one, the pair 10. Similar to last question, we just orangely is sine omega 0 t. This is small t, which is corresponding to ft, and its Fourier transform is g pi delta omega plus omega 0 minus delta omega minus omega 0. And for this part is the Fourier transform. And also we since the duality property and sine function is odd function, which means like sine t equals to minus sine minus t, something like this. So we can get sine minus omega 0 omega equals to minus sine omega 0 omega, and its inverse Fourier transform form is, if we treat this first, we treat this f minus omega, so its inverse Fourier transform is g over t over 2 times delta omega 0 minus delta omega t minus omega 0. And this part is 2 pi, 1 over 2 pi times capital F t. We set omega 0 equals to capital T, and times minus 2g for this pair. For this pair, we can get 2g times sine t capital T omega. And inverse Fourier transform is delta t plus capital T minus t minus capital T. So we get the answer. Okay, next question is using the time shifting property, show that if f small t, its Fourier transform is capital F omega, then this pair is correct, and this is the dot of the equation 4.41. We just prove this, and then using these results and pair 17 and 19 in table 4.1, find the Fourier transform on signal of these two figures. First, let's prove this this pair is correct. Based on the definition of the Fourier transform, capital omega equals to the integral of negative infinite to infinite f small t times e to g omega t dt, and we set t prime equals small t plus and minus capital T. So we can, from this this expression, we can get f omega equals to the integral of f t prime e minus g omega t prime dt prime. And then let's do some deformation derivation. So this is minus capital T e minus g omega t plus minus capital T d t minus plus capital T, and then we can get e minus capital T and integral of the ft minus plus capital T e to minus j omega t, and since t is a constant here, so it's just dt. So we can get for this part, actually this is for this one is the Fourier transform. So it's f omega so so this is e times plus t, right? And then so from here we can get the ft plus minus capital T, its Fourier transform is f omega e plus j omega t. Oh, sorry, there is j omega. So so we can know that if we separate t minus capital T plus f small t minus capital T, we can get f omega. Its Fourier transform is j omega t plus f omega e2 minus j omega t. And based on the Euler equation, which means e to j omega t is equal to cosine j omega t, cosine omega t, cosine omega capital T plus g sine omega t. We know that this we can get more duration, more simplified, which means 2 cosine t omega and times f omega. So this equal to this one. So we got the improvement. So now we got the improvement, which means ft plus capital T plus t minus capital T. Its Fourier transform pair is 2 times f omega times cosine t omega. So we get improvement. Then next we calculate we get a Fourier transform of these two figures. For the figure A, we use the pair 17, which is this one, since it's a rectangular function. And next question is use this pair. Okay, for this one, first let's see the definition of the rectangular function. for a rectangle function, the definition is if this is a and z, and this is t, this is xt, and rectangle function t over a equals to 0, 1, absolute value t larger than a over 2, and equals to 0.51 capital T, absolute T is equal to a over 2, otherwise is equals to 1, others. This is the definition, and we can see in our figure a is equals to 1, and a here is equals to 2, and according to the pair 11, which is pair 17, which is rectangular function t over tau, its Fourier transform pair is tau sinc function and omega tau over 2. So we can get a rectangular function t over 2. Its pair is 2 times sinc function and omega. And from its figure, we can see it's capital T is equals to 3. So based on our we already get T f minus T minus capital T, its Fourier transform pair is cosine T omega. So it's equals to, for this one is 2 sine 2 sinc function omega. So this part is 4 sinc omega cosine 3 omega. And for the next triangular function b, we similarly, first let's see the definition of the triangular function. Its triangular function is something like this, and the cross point is tau minus tau over 2 and tau over 2, and here is 1, 0, t, and the triangular function definition is t over tau equals to 1 minus 2 absolute value of the t over tau. Absolute value t is smaller than tau over 2, and otherwise is equals to 0. We can see the tau here is equals to 2, and according to the pair 19, which is the delta function, the triangular function, the Fourier transform pair is tau over 2 sinc square function omega tau over 4. So here is tau is 2, so we can get more derivations. T over 2 sinc square function and omega over 2. So we can get the final answer, which is t minus t and 2 times capital F omega cosine capital T omega, and here is 2 sec square 2 omega over 2 times cosine 3 omega. Okay, so that's the answer of this question. Thank you.